So question 7 looks at density and the measurements we have to take to calculate density. We're given an irregular object. Now if it were a regular object, say something like a cube, like my wonderful drawing here, you could use a ruler to measure the different sides of it and use the appropriate equation to calculate the volume. However, with an irregular object that's very, very difficult, so we have to find another way of measuring its volume. So the first thing I would do would be to measure the mass of the object with a top pan balance. So it's a balance, not a set of scales. I would then part fill a large measuring cylinder and record the initial volume. So read off how much water is in there. I would then submerge the object in the measuring cylinder and measure and record the final volume. Now whatever that increase in volume is going to be the volume of the object, so it's going to have displaced the amount of water that's equal to its own volume. So if I were to do final volume minus initial volume, gives me the volume of object. And then my last step would be to use the equation density is equal to mass divided by volume to calculate density. So use density as mass divided by volume to calculate density. Another guy did a similar experiment to determine the density of 5 common plastic materials. So acrylic is plotted on here around, nylon, that's on there already, and then we have to do the rest. The tricky thing is that they haven't included a scale for the y-axis. So if I have a look here, well, nylon goes up to the second big division there, and if I look at nylon, that is 1000. So that tells me that this must be 1000. That suggests that this will be 500, and we're starting down at 0. That making this one up here 1500. It's asking us to do polyester, so 1380. So each of 2 squares represents 100, so that will be 1100, 1200, 1300, and 80 should be about here. And I'll use my ruler. That down. Polystyrene 1040, so that takes us up so there's 1000, 1040 will be just below that second one. Try to make your bars the same width, unlike me. Something like that, and the last one, 1100, that's a little bit easier. So to 1000 and then up 2 squares. So it should look something like that. And again, your marking points will be for getting the right scale and for getting the bars to the right heights to within 1mm. Last question looks at different plastic materials. They measured the density of the same material 3 times, and they had 960, 1120 and 1040. And we're asked to determine the uncertainty in the students' results. So if you were trying to do the uncertainty, it's half the range. So uncertainty is equal to a half the range, and the range equals largest minus the smallest. So we would do the largest 1120 minus 1040 oops, and I've misread that obviously. So 960, I beg your pardon. So that's our largest, that's our smallest. 160. So the range is 160. So we have to divide that by 2, and that will give us our uncertainty. So in this instance, the uncertainty is 80 kilograms per meter cubed, so plus or minus 80.